Good evening, everyone. Thanks for joining us once again. This is the AI Ghana weekend webinar. We are joined here with Foutse, a machine learning researcher, a volunteer at sorry for saying Corona, Concordia, Ile-de-France, and a recent graduate from a master's degree in information and data processing at University of Paris Saclay, France. She'll be presenting on sentiment analysis on tweets regarding female sports. I would like to take this opportunity to say, give a big sorry to you, the participants, for the last webinar on this same topic. We had some issues with our connections and all that. So we didn't have a smooth one, which is why we've decided to give everyone the fair opportunity to benefit from this most important topic. So she's going to take her time and run us through the research that she has done and present to us her interesting results. Foutse, it's up to you. Thank you.
Okay, thank you very much for giving me the opportunity to share my work with you guys. Welcome to everyone. As I was already introduced, I will go straight to the subject. Here I'm presenting to you a work that was done in a context where the aim was to sensibilize on the realities faced in sports, especially focusing on the biases regarding genders or inequalities regarding genders. So, oops. My presentation plan is as follows. I will situate you in the context of this work and the motivation, talk a little bit of the theory of the area that I focused on for this presentation, and then dive into the applications which I did and the final test on the tweets in question with a conclusion. Going to the context and the motivation, during this study, exchanging with various sports and non-sports people, many people had different definition of what a mixed sport is. Some see it as a sport where both gender do the sports, but not necessarily competing against each other, but each gender separately, like the case of football right now. But others see a mixed sport as a sport where both gender are competing against each other, like the horse. Or others see it as a sport where the opposite genders face each other and it is challenging. You cannot know who will win. For them, that is a mixed sport. That is a sport that is equally done with by both genders. And others see it simply as a sport where in a team you have both genders, which is the case of tennis. In nowadays, we now have tennis that is done with both genders in a team. So and trying to investigate on the various aspects, specifically what we found on the financial aspect, we saw that there is a huge gap between female sport and male sport. And so we were wondering, is it due to lack of mediation, sponsors, supervision, or some negative stereotypes that are out there regarding female sports? For instance, we realized that a huge company like Book Telecom during the female football sport could send messages to people discouraging them to follow the female sport, like talking like, what do you expect? Like, it's obvious that it will be trashed. Pardon my harsh word, but it's just a little bit of what the message said, which I left the link in case someone wants to check out. And more still, TF1, a big company that we all know, also did the same, making silly comments regarding describing an action that is being taken part during the female sport. And we have the former champion of judo, who is also a celebrity, who estimates that the female should stay at home, not get involved into sports, I guess, like judo, what he's doing. So all of this showed to us that there is a problem in the field, and majority of us that were studying it didn't actually know all those pitfalls that we found, and via this project we discovered them, and I'm about to share it with you guys. So basically our approach was summarized in this diagram. We started with an interview where we went towards sports personalities and exchange with them to share with us what they experience in the sport environment, both male and female. Then based on the discussion we had with them, we provided a Google form where we had some question and answers, and tried to share it to the general public and see what they think about. And in parallel, we were trying also to analyze on the media how are people talking about female sports, which is what I want to emphasize on this webinar. And for the social media analysis, we focused on Twitter, which is why you hear the topic, sentiment analysis on tweets regarding female sports. So diving first into the theory of the work I'm about to present to you. Given that I was told that my audience is a mixed audience with both experts and beginners in the field, so I thought it wise to share a little bit in the theoretical concept in a general manner so that others could discover other fields in the area. So basically, the main branch of this work is NLP, where here we analyze mainly text, and text is analyzed in various. It could be in machine translation, as we see in Google Translate, information retrieval and search engines, for instance. It could be in information extraction. It could be question and answering, even via chat box, and sentiment analysis, which is what I'm about to talk. So what is this sentiment analysis all about? Well, mainly the goal in this area is to be able to give a sentence, a phrase, or a text to some model, and it should be able to score it to tell you how positive that statement is, how negative it is, or how neutral it is. And this can also extend to different degree of measurement. Some studies also do how very positive or slightly positive. So it depends what's the aim. So basically in this illustration, it's mainly giving a text to a model that has been trained to be able to know when a statement is negative, and the model tells you whether the statement is a negative one, a neutral one, or a positive message. In this analysis, several steps are involved, mainly based on what's the objective, what do you want to achieve, what do you want to do with the text. So the common steps are as follows. We have a tokenization, stemming, lemmatization part, where here it is mainly taking a raw text, trying to segment it and get rid of some statements that kind of are similar, and also statements that will not necessarily give you additional information in that statement. So there are pre-processing techniques that you might use, and we have the NLTK library in Python that helps us do that. And then once that is, when you have your clean text, now you want to extract features from it, and it also involves various methods. We have the method of back of words. We have 10 frequency, inverse document frequency. And we have word embeddings. It could be word to vec or glove. These are basically techniques to help you extract pertinent or relevant information into your text. Once all that is done, the next step is to choose an appropriate model for it. So here I try to illustrate to you a bit some examples of the terms that I used regarding the various methods to extract features from your text. We have the term frequency TF-IDF, that basically from a text it is able to pick out rare words in a text, but that are really meaningful and helpful. And we have word to vec that tends to kind of link words that are alike in meaning. Like here you illustrate like women is to men, uncle is to auntie, gender-wise. And you have the glove, that is another kind of method that makes use of probability techniques to get that similarity into words and trying to kind of classify them accordingly. Going into the application, because on Twitter, we tend to express how we feel about a subject, we thought it wise to use that as our main focus, our case study. So in Twitter, basically, you have a specific length of words that you can enter on your statement. And generally, you express your opinion about a subject, and everything is clearly identified. You can identify easily an author of a tweet or a responder with arrobas, and you can identify the topic with JS, and you constantly have new data, new comments, reactions, and people tend to communicate best via that field, via this media. So that was ideal for us. Then we then went on and tried to identify some topics that could help us extract people's opinion or expression regarding this topic. And our first example was taken with the following hashtags topics: female sports, girl sport, female football sport, and so on, you name it. And here I tried to visualize where does this tweet come from. And I noticed that mainly it comes from English-speaking country. Of course, I used the English hashtags, so that's not that surprising. And fortunately for this, there exist Python libraries that could help us easily detect in a text, in such text, whether it is a positive or a negative statement. So we use the library text blot, which takes in a sentence and will give us a number of parameters where the sentiment polarity is part of the parameters that gives us a sense of the positiveness of the statement. So that was applied to our first extraction of tweets, and we got this result that I show here, and we can see that we kind of have more positive than negative, although it is not so big, but at least we observe that the tweets tend to be more positive. I illustrate here an example of how you could see and try to picture how the model classified its polarities with corresponding statement. So we can see from the first statement, most excellent women in sport from pages, and we can tend to think that this statement was characterized as positive due to the word excellent, kind of, and which is not wrong, I guess. But the problem is this study is mainly because the remarks we had was in the French context. All those companies and that celebrity I showed that made unpleasant comments are all in France, and France is a French-speaking country, so obviously we don't have a lot of tweets coming from France. So what we did next was to use French hashtags so that we will be able to have tweets, that is comments that comes from people in France. And we did that remaining in the same time frame. So we still extracted from June 2020 to February 17 February 2020. And this time we extracted this hashtag, these topics, Journée internationale du sport, all of this, and then try to try to visualize where does this tweet come from. And from our visualization, we can notice that majority is from France. But you see the places that appear bigger is due to their frequency in my database. So we can see that many people come from Paris, from Toulon, which are French places, Toulouse, well, and other places, but at least we can be confident that we are analyzing something, at least that the majority comes from France. But then many existing libraries are more adapted for English language. So one difficulty I faced when I tried to apply the same text block on my French suite, it didn't make sense, the result I had, because I kept having a zero, even whether the statement is positive or negative. So I understood that it's not adapted for the French language, unless there are some pre stuffs that I had to do. I don't know. But that being said, generally I noticed that not a lot of tools exist to handle the French language in this context. So my option was to build my own model that will understand the French language. But now, before I build the model, which model will be adapted? Which one should I use? Well, many models exist out there. We can use LSTM, we can use neural networks, we can use convolution or recurrent neural network. But then I decided to use convolution neural network 1D because basically I want to train a model that will not focus more on the context of my database, because first of all, I did not get a database that is in the sports context already. And so the 1D CNN is one of those methods that does not take into account like what was done previously. I mean, in a sentence, it just take part of the sentence and analyze them. On the contrary of something like LSTM, which keep in memory the previous aspect and takes that into account when treating a text. And that model being chosen, some few regularization technique that I used during my building of this model was the global marks pooling and dropouts. I mainly tried to regularize my model to obtain something significant using the dropout by varying the percentage of the connections that I kind of dropped. So basically in this image, I tried to illustrate how that works. In the process of the training, in each layer, we randomly kind of leave out some connections while we are doing training, so to avoid overfeeding, so that each layer should not too much depend on each other and so on. So to build my model, I needed data, and it was much easy for me to do a supervised learning on my model. So I needed some data that was labeled. Hence, I went on a website that has content that was noted. And in my case, I went on a movie website where I had people reviewing some movie and giving marks for those movie. So I made use of web scraping technique to extract that data. So in this image, I tried to illustrate briefly what web scraping is all about. Basically, you go on a website that is of interest to you, and you select, for instance, here, we select here, and we inspect it to analyze the HTML behind and try to see what are the things that you need to include in your code in order to collect the right information you want to collect. So on the website I used, mainly these were the movies that were on the website that were reviewed. And totally I had a data set of around 256,346 reviews that was reviewed by 48,163 single reviewers, unique reviewers, let me say it like that. And it contained 5,325 movies. So I had a data set of approximately like this. And since my ratings are kind of not well distributed, like I have a lot of 5 and 4, and since I am interested in building something that will tell me, a model that will detect a positive statement, a negative statement, or a neutral statement, I then did some pre-selection in my model and took only the reviews that was rated 4, took also reviews that were rated 2.5 and 3, and took reviews that were rated 0.5 and 1 and 1.5, which I then grouped into ratings that were from 0.5 to 1.5 to be 0 as negative reviews, and those that were in this range as neutral, and those that were rated 4 as positive. And then I had my new distribution, which is this, and which is kind of, well, almost equally distributed. And this is what I used for my model. And now at the end, this is the size of my, this is the size of my database now. I had something like 56,793 data. After that, I did some pre-processing on my model where I kind of removed unnecessary symbol in my data, put everything to lowercase, remove stop words, and then built a dictionary of the 10,000 most common or most popular words in my data set. And here is a visualization of the words, of the words that were mainly used. And so we see that Siri is mainly used, c'est très, plus, set, and so on. Then I built my model. So my model was structured to take words that were of length 500, which is specified here. And I had a dictionary of 10,000 words. That's the maximum number of features. And my benzene length of 64. And I initialize my model with this syntax. where I add my first embedding layer, and followed by a dropout of 0.3, followed by a 1D convolutional layer with an output of 64, with kernel size of 3, with a ReLU activation, and so on and so forth, and used an RMS prop optimizer. Well, here when I was doing all the training and trying to have a model with good accuracy, I kind of danced a little bit more here, trying to test different optimizers, and finally got this one who gave me something that was not bad. So I trained now my model, splitting my data into a train size of 46,793 and a test length of 10,000. And each of my statements was converted into a vector of integer based on putting their equivalence in my dictionary. So since I had a dictionary of 10,000 words, and each word had a number from 1 to 10,000, and then on each of my statements, I put the equivalence of the number of its equivalence in the dictionary, and that is what I pass to my model. So I pass a vector of integer to my model, and I did the training over 10 epochs, leaving out 20% for the validation test during the training, and I got an accuracy of 68.93%. So another observation that I made when I was training my model to make sure I am not doing some overfeeding, because at some point I had a lot of overfeeding where I had a lot of divergence between my validation test and my train. And I show out this image maybe to emphasize that it is important during training to try to follow the behavior of your model, because the ideal situation you want is that these two graphs should not diverge too much. And here we see that it diverges a little bit. So training it further and further will not give me that much difference. We see that at almost maybe 3 epoch, I was even supposed to stop at 3 epoch. And that was also observed in my accuracy. My accuracies didn't change that much. So this model that I trained was then tested. The model trained that you just saw was then tested. I started first on a simple phrase where here I wrote it myself. Le match était très nul. Poof. This is to say the match was so bad. And then my model predicted it like this with 93.98% to be a negative statement, and 0. That will be 5% of neutral, and very, very low for for positive. So this gave me hopes that although I don't have a huge accuracy, which I was looking for, at least it makes sense what my model gives me. So I went further to apply it on the tweet, the French tweets that I extracted. So globally, I had 160 French tweets. I think so. I forgot to include the size of the tweets here, but well, the processing done on the tweet was what I already spoke about. Get rid of the all the URL and all the stuffs, unnecessary stuffs, and then once I did all the pre-training and I applied my trained model using my dictionary, the same dictionary I used to train my model with. And then I got the following results. We see that on those tweets that I extracted, I have 84 tweets that are negative. I have 20 that were classified as neutral, and I have 56 as positive. So here we have a situation of more negative comments. So this, in conclusion, told me that our model on the model built from scratch gave us told us that with the French tweets we have more of negative comments regarding those subjects that I used to extract, and it kind of is in line with also the comments I found when I did the research regarding comments on the female football in France. They were also negative. And that just simply tells me that maybe the situation is not that high or that fair, because there is a lot of negativity around the topic, and maybe females need to be more encouraged in the field of sports. And then that also points my attention that given assuming that the same principle holds, we had extracted in the same time frame some tweets in English and got more of positive, although it was not the same subject. But basically, what it could sting to in our ears is that the English-speaking countries tend to be more positive in their comments regarding the female sport compared to the French-speaking countries. But then this just limits to the data that I collected. That's just it. So maybe further support need to be given for the female sport in the French-speaking country. That was my conclusion. But yet still, this study could be furthered with more data, because I did not have a lot of tweets and topics, various topics to handle and really do the comparison. So this is just a flash on what we just got, and yeah, that's it about the study. And I thank you very much for listening to me. I welcome on your question, and if you want, maybe some parts of the question might require that we go into the textbook, I will feel free to tell me. Thank you.
Hi, Foutse. Thank you for your wonderful presentation. I think that there are some few questions for you. Um, from this one from Francis Okoye, he says, how do you remove the irrelevant text to only the keywords? What is overfitting and how do you avoid it? Also, how do you get the data from the tweets, and can you also extract comments from IG and Facebook?
Okay, how do you remove 11? Actually, I remove the irrelevant. There are libraries that permit you to remove, first of all, stop words that adds no meaning to your sentence. I use them, but then once I also visualize, like manually, the text that I have, and I notice some kind of strange symbols due to the extraction process, some irrelevant stuff, I add that as one of the things I want to remove in my database. So that's what I do to remove those things. And overfitting here is a situation where you build a model to know exactly, like to memorize the data you are training him on, in such a way that if he is on a new data, he cannot guess it right. So usually you have that, you will train and have an accuracy maybe of 99%, but once you give it another data, it won't be able to tell you, because it has mastered just what you gave it, just the training. So that's why you need to make sure, pay attention that you build a model that will not overfit. And to extract the data on Twitter, you have the Twitter API that helps you to do that. And I guess you also have APIs for IG and Facebook that will help you to do that.
Okay, that's cool. Thank you for your answer. We still have some time. Could you go to your notebook? I guess you would want to show us something.
But basically, I will just be showing you the code because
Sure.
yeah, there is a, does that mean training on balanced dataset classes lead to overfitting? Yeah, overfitting in the sense that your model will master the data you use, but that's not usually what you want. You want to train a model on something, but you want it to be flexible when it encounters new data. So yes, you cannot just avoid overfitting by having a balanced data set. No, you can still have overfitting if you have a balanced data set.
Okay. This one from Lionel. He says, thanks for your nice presentation. How do you ensure that you are not introducing bias from movies to your model?
Using what?
How do you ensure that you are not introducing
Like
bias
what
from
kind of
movies to your model?
what kind of bias, for instance? Because actually, when during the training, I try as much to not make my model not to focus on movie specific subjects, so I get rid of them. So I think if but because personally when I was doing this, I didn't really see if a kind of bias will occur in this context. So I don't really understand what kind of bias we can have here. But if I am in a situation where there might be biases, I will try to remove in my statement, in my database, those statements that are to too specific. Like if I give a vague example, which is not even in this context, like for instance, you are building something to extract CVs for a recruiting process, and if your model is taking into account gender, for instance, it will not be good. So ideally, what I will do, I will remove that parameter in it. So in this context of text, if the bias is in some terms that might be used in the comments and that I identify them, me, what I will do is that I get rid of them in my database as well. They will be part of the words that I get rid of in my database, and then take just the words that are kind of neutral to the topic in question.
Okay. This one from Leonel again. By the way, thank you for your answer. I think reviews from movies are different from reviews from sports. So using movies review can be biased, no, can bias the model.
Mm,
That's
yeah,
from Leonel.
yeah. I don't disagree with the fact that reviews from sports, from movie will cannot be the same if I had reviews on sport. Exactly, that is why I used a model that will not so much focus on the context in question. Basically, in my statement, I try to pick out words that characterizes a positive statement. For instance, in a statement, if I find a very good job or very good, very good something, what my model here might take is the very good as a key thing that he will say. But then if the context was to have if the task was to have the context of the phrase before deciding if it was positive, I think my model will be challenging in that it will not be able to do it correctly, because basically I don't take the context into account. And just the fact that I don't take the context into account, I think I am not so focused in the context of movie.
Okay. Yeah. Cool. Thank you. So we still have some time. Now, kindly differentiate between like when you train for the English version and the French version, the different data set that you use. I think that differentiation should be made clear. The fact
What
that NLTK was basically used for English and the web scraping was
text
done
block you mean?
for French.
No, text block. You mean here
Yeah, yes, yes.
that I should do what? What's the question?
I mean, state the fact that the training was done in two ways. One for English, okay, using the NLTK, and the French
Using
part, which,
text block.
yes, text block, and the French part, which dealt with the web scraping from the movies review, you know.
Yeah, here for the movie, for the reviews that I extracted in English, I used a Python library. So I actually didn't do much on it because the library in question, this is it, the text block. It's a library that gives me the sentiment polarity of my statement. But then this library gives in English, it gives the sentiment, it's capable of giving me the polarity, giving me an idea of whether the statement is positive or negative. But in French, it doesn't. So that is why I had to build the model that will help me identify a positive statement in French. So I had to build it from scratch, and so I needed data. That is why I have the scrubbing part. The scrubbing part is mainly to get some label data that will help me to train this new model I want. And now it is based on my new model that I want that I applied on the French tweets, which which was extracted using these subjects, and
Okay.
I applied my model on. I don't know if that's what you expect.
Okay, yeah, yeah, that's cool. So Lionel, on the same question about movies and bias, he says another way to see that is the following: why
Yep.
you didn't use unsupervised learning, that is K-means or GMM, something that can model the distribution.
Okay. Wait, was that the question or was telling me something? I
Yeah, so he's asking why you didn't use unsupervised learning, like
well,
K-means
I didn't
or
know how
GMM.
to. Pardon?
Well, he's saying that another way you could look at the bias problem, how, like what he was talking about, is that, I mean, why didn't you use unsupervised learning? Like,
Yeah, I
okay, uh-huh.
use it
So
on what, on the tweets, or
what you used to build your model,
like
So
use
he
just
K-means
the
or
text
GMM
and not the reviews. Not. Can he
on
speak?
your data set, he means.
My on my data set.
Yes, that's what he says.
No, I went to take that data set because I wanted a data set that had label because I I don't think I can do CNN with unsupervised.
On your
I
tweets.
needed data with labels. So, but if he's requesting to do a totally unsupervised study, yeah, that will be ideal. But I didn't know how to do that on text data. I didn't uh, I didn't lay more emphasis or search on the techniques to handle that on the data, because if I knew that, I will simply apply it on the tweets that I extracted and separate them into breath and allow my model to separate it for me, I guess. And that will give me an idea of the context. But then I will not be really able to make a comparison between what I obtained from from the tweets in English. So this approach permitted me to kind of situate the two studies I did.
Okay, cool. I think that we do not have more questions now. So if you wanted to show us something on your notebook, that's totally fine. If not, I think we could just wrap up.
Well, I don't really know what to share because basically it's just for if someone wants to kind of see the parts that was involved. And yeah, this is but my PC is kind of tired, I guess. So this was my data set with the various labels, which I did some removal. So I kept these guys. And then on this guy, I did this pre-training that I explained to you guys to build a new data set which gave me this. Once I had that, I kind of put everything to lowercase and split them.
Yeah, hello.
So do you have a question now?
Okay.
They,
No,
I
go on.
okay. And
You go on.
and so here is my new data set, which I extracted the most popular words and tried to. Someone asked how I removed. These were the kind of symbol I also found in my text, which were so often, so I get rid of them. And all this pre-processing to have this, that was my data set that had the things that I qualify as reasonable words that were relevant to pass to my model. And then I built up my dictionary, which I later on saved to use later when I want to test my model. So this was my, like I explained to you, the 10,000 most common words. I store it in a dictionary and I give them numbers from 0 to 1. And now on each of my text that I pass to my model, the phrases will take its corresponding number here, and if it is not found here, it is been getting rid of. So that is how I did the transformation and got now my new database that contains indices that represent what is in my dictionary. And that's being done. This is the part where I separate my models into test and train, doing the one hot on my labels, and and build my model now here, which I showed to you guys. And I think this is the architecture you were talking about.
Yeah, exactly.
Mm. So this is it. And now I trained my model for 10 epochs. This was the evolution I was analyzing. And we see that at exactly we didn't really have much change, which explains in the graph as we see. And then I tested on the test data set kept aside, and I got this, and I saved it. And tried also to visualize how the model behaves on each of my classes, and kind of behaved in a fair manner for the negative and the positive, and the neutral. It was kind of hard to detect a neutral element from what I saw. So once I saved my model, I this is the part where I tested. So I load back my model and my dictionary, and this is the phrase I took for a first test. and do the pre-processing to put it in a form that my model will understand. And once that's done, I pass it on to my model, and it gave me this, showing me that the 93% it is a negative statement. So that gave me some confidence that at least it makes sense, the results that it gives. So I now took my tweets, the tweets that I had already extracted before, and this is just my visualization of the tweets coming from 30 distinct places. No, from 72 places, because I had some tweets that did not identify the location. And now here I just tried to visualize the various places from where they were coming. It is necessary because the aim was not to just analyze tweets that were coming from everywhere, but from my data set, I clearly see that majority is coming from France. See a lot of France employed everywhere. So this is an example of the tweet. You see, there are stuffs that are not cool. There are characters and blah 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 et tout ça. So I removed it like this, get rid of them, and this is the clean tweet. And I did some breath test, just putting it in a data frame and put everything to lowercase, split it, do the transformation so that I put it in a form that my model will understand, because my model was built to adapt to statements of length 500. So if it's less than 500, I complete it to 0. And same thing is done. The phrases are changed into their corresponding indices in the database, in my dictionary, pardon. And then I transform it into a shape that was understood by my model, and I do the prediction and got this prediction. And yeah, so here is just putting it in a nice form to plot it later. But then I went further to a little bit investigate what it gave me to see if it made sense. So I tried to look at the result of one. You see, this statement says 24 février 2020, rencontre de lancement du vivier d'expertise féminin dans le cadre du programme leadership. You see, this statement is really not negative nor positive. And my model, you see, kind of didn't give good, like 99 on the neutral, but then the highest probability was at least on the neutral. So that's it. And for a statement like champion adulte et grand champion du concours agricole du bon vin comme des vaches en trois, this is actually an insult in French because it's comparing human being to a pig. And my model at least did not know it for sure, but yet still the highest probability was for the negative statement. So that's it.
Okay.
That's,
Cool. Thank you.
yeah.
We have Rufus, whose hand is up. Let me try to let it unmute. And
hi, how's everyone?
Hi.
I just want to ask a question on how you choose. Can you hear me?
yes, go ahead, Rufus.
I just wanted to ask a question on how you choose your best model. Did you try to find the best model by trying all the model? How did you know that the model you used was going to be the one with the highest accuracy? I mean, if you are given a problem on sentiment analysis of text, how do you get the model that will give you the best accuracy?
So basically what I did here is first identify the model that was suited for my case. And like I explained in the presentation, why I used the CNN1G was basically because I did not want to focus more on the context in each of my phrases. I wanted my model to kind of pick out those keywords that distinguishes a positive phrase and a negative phrase. So once I was situated on that kind of model to use, when I do the training now, I tested different optimizers and trying to play around with the regularization. And on the optimizers that I used, I had different results and different behaviors on the graph here that I was showing, because I was trying to make sure that I should not have a model that is having a so high accuracy, whereas it is just memorizing this data and not performing well on the test set, because I had some situation like that. So basically what I did here, I played more on the optimizer I used. I tried various optimizers that gave me different accuracies. And I tried also to vary my dropouts and added some layers to my model, reducing them. So basically that's the kind of manipulation I did. But I guess in a different study, in a context where you need to know the context of the phrase before you decide whether it is correct or no, you need to use maybe models like LSTM that keeps memory of the previous stuffs. Like you have a chain of words and you don't want to forget the previous ones once you are handling the next word. So in that case, if that is so important, you should use such models, STM or aighana. But then since I did not have the appropriate data set for the specific task that I wanted to do, I thought it was not so important to have to build a model that with so much focus on the context, because in any case my aim was not to go and my aim was not movie review, for instance. I don't know if I answer your question.
Okay. I think you have in a way. Thank you. We are running out of time. In fact, it's time. We've already used our 1 hour time. So I think we can call it a day. Thank you very much, Foutse, for
Thank you
um,
very much. It was my pleasure to share this with you guys.
cool. I wanted to know, are you willing to share these codes with us? I mean, is it open source?
I will put it on my GitHub and you can check
Share
it
with,
out whenever you're interested. But I guess
and
I will not put the scrubbing, because I guess it's not appropriate to share the website where it's the scrubbing, else you will have a huge, you might saturate the people's server and stuff like that.
sure,
So I might not
sure.
share that one, but the
Okay,
analytics, this and this that I showed here, of course I will put them.
okay, no problem. Okay. Once again, thank you very much. And hi, the AI enthusiasts, I mean participants, we thank you for being with us today. Um, so I am John Bagiliko, the co-founder and team lead of AI Ghana, also the Zindi Ghana ambassador. I have been doing this with a really great lady, Deborah Atta. She's a student of the University of Cape Coast, who has been like a backbone. So I just wanted to say thank you to Deborah. Um, so once again, thanks everyone and have a great time. Bye.
Thank you.
Yeah, bye. Thanks.